The three next slides will be questions that we can work through, and exam type question, so you really grasp the concept of density and snow and fern and ice. So what would be a reasonable density of fern that's 10 meters below the surface of a glacier? You have the choice between different densities. I'm going to give you the answer for that one. A reasonable density for fern is 0.5 kilograms per liter. 0.1 would be the density of fresh snow that just fell on the glacier. 0.9 is the density of ice. And we said that water in its solid form cannot be more than 1 kilogram per liter, because the liquid phase of water is its denser phase. Therefore, 1.4 kilograms per liter is a completely unrealistic answer. So right answer here is answer B for fern. Now let's go through this exercise. So in this exercise, we want to know, we just had a fresh snowfall, and we want to know how much water is in our snowpack. If we melted all of that snow that we have, how much water would it represent? So you are either a skier or a glaciologist, and you're super lucky because there was 3-meter snowfall that just fell on the mountains. And luckily, you know that this density of this snow is 0.5 kilograms per liter. So if you're attentive to the last question, we are actually more in the realm of fern in terms of densities. But let's say that we have a density of half a kilogram per liter. Then you want to know the SWE or SWE, snow water equivalent. That is the amount of water that would be represented by the snow if we melted all of it. Raw snow is the density of snow, raw water is the density of water, and V is the volume of snow. So the formula says that the snow water equivalent is equal to the density of snow, 0.5, divided by the density of water, 1 kilogram per liter, multiplied by a volume. In this case, we'll say that we have a volume of 3 cubic meters. So you draw on your snowpack a cube that's 1 meter per 1 meter, and actually, yeah, 1 meter per 1 meter on the surface, and you know that you have 3 meters of snow. So if you multiply all that together, you have 3 meters of snow thickness multiplied by 1 meter multiplied by 1 meter, and that's equal to 3 cubic meters of snow. If you plug that V value in the formula of the snow water equivalent, you obtain 500 divided by 1,000, 500 being the density of the snowfall, 1,000 being the density of water, multiplied by 3. And what you obtain is 1.5 cubic meters of water, so equivalent to 1,500 liters of water. To get from cubic meters to liters, you simply multiply by 1,000. So 1.5 multiplied by 1,000 gives you 1,500 liters of water. You have everything that's detailed on there, so don't hesitate to put the video on pause and to look at that a bit more in detail.